Welcome, welcome. We are going to look at how to get a graph given a word problem. And we're just going to do two quick, very basic word problems here. Not going to go too in-depth. I mean, if you understand the process of how to get to your answer to the first and the second example we're going to look at today, you're going to understand how to do pretty much all of them if you follow the same set of steps, okay? We're going to be talking about Tyrone and his taxi. Tyrone's taxi, all right? We used to have these things before Uber called taxi cabs, all right? And Tyrone in his taxi, he charges a $5 flat fee plus $2 a mile, okay? So what the flat fee is that is how much it costs just to get in Tyrone's taxi cab. All right, it's $5 just to get in, and the reason he would do that is because if you're only going a half mile down the road, you'd only be paying half of $2 because if it's $2 a mile, you'd only be paying him $1, and it's not worth his time. So a flat fee is what we call a constant. That's what you're going to pay if you went 0 miles. And I understand it's like, why would I go 0 miles? That just the logic of. If you understand the logic of what we're talking about here, at 0 miles, it's going to be $5 because you still have to pay that just to get in his taxi cab, okay? We are going to come up with a title for this. So a good title for this graph would be something along the lines of taxi cab charge, all right? Or, Tyrone's taxi. Now I want to be a little bit more specific. Tyrone's taxi cost, all right? I mean, if you just put Tyrone's taxi, it's like, all right, well, what are you talking about? Are we talking about the color of his taxi cab? We're talking about the cost of his taxi cab. We have two variables that we're discussing here. The two variables, I mean, we're not talking about blankets and horses, all right? We're talking about how much money it costs and that's dependent upon how many miles you go. Your independent variable is always going to go on the x-axis here, okay? We have our x-axis, we have our y-axis. You are going to put the independent variable down here on the bottom. We have miles, remember, and we have dollars. So those are our two, we have miles and dollars. Those are our two variables that we're discussing here, miles and dollars. So if you don't know which one goes on the bottom, generally speaking, if we're dealing with time is going to go on the bottom. In most cases, we're going to put the independent variable on the bottom. You have two variables here. You could either say the dollars that you pay depends upon the number of miles, or you could say the number of miles you go depends upon the number of dollars that you spend. The second way I just said that doesn't make any sense. Like, the number of miles you travel depends on how much money you spend? No. The number of dollars you pay depends. So the dependent variable we're going to put up on the side over here, this is going to be the dollars. Why is it? There we go. And this is going to be the number of miles that you travel. The number of dollars you spend giving to Tyrone depends upon how many miles you go. Now, in this question, if it said every 30 miles you pay him $50, then you would probably want to go by something different on the x-axis. But since it says per mile, which is understood like per 1 mile, we're going to go by ones down here on the x-axis because you're talking about the number of miles. It's like it's meaningful to say, all right, how much is it after 1 mile? How much is it after 2 miles? So on and so forth. On the dollar amount, the least amount of money that we would end up paying Tyrone if we went 0 miles would be $5. So if we start at 5, if we went by ones, it's like your first ordered pair would be all the way up here. Like if this would be 5 if we went by ones. So, and that's not wrong. I mean, your graph is just going to be somewhere up here. That's not wrong. It's just, let's go by something other than ones. Let's go by something that makes sense. Now, generally speaking, we don't go by 6s or by 13s, you're going to want to go by a nice, neat little number like 1 or 2. 3 is even possible. Like, we typically don't go by 4s. You can, all right? It's not going to be wrong. I just want you to, you're not going to get a graph in which the y-axis goes by 12.7s, all right? You're going to want to go by a nice, neat little number. I'm just going to go by 2s here. 2, 4, 6, 8, 10. So our ordered pairs are probably going to be in the middle. All right, so let's think about this for a second. It's a $5 flat fee plus $2 per mile. We discussed earlier this year the thing that's happening over and over and over and over and over again. How much you're paying every mile, $2. Every mile, $2. So you're going to have a number that gets the variable, or the number that's being multiplied by your variable. You're going to have a number that's going to be standing alone. So your expression for this would be, it's 2m plus 5. Or you could have written it 5 plus 2m. We're going to start writing it like this. It'd be 2m plus 5. And that's going to be the total cost for his taxi cab. So you could say the total cost would be $5 plus $2 every single mile. So you're going to multiply by 2 for however many miles you're going. But you have to add on that $5 to begin with. Look, if you're going to go by 2s on the y-axis here, go by 2s. But what you can't do is you can't start here at 5 and then go by 7, 9. You can't go by a different amount. Like from here to here is 5, but from here to here is 2. You got to go by, if you're going to go by 5s, go by 5s. You're going to go by 2s, go by 2s, but you can't go by both. You can't go by 1, 2, and then 5, 10, 15, all right? Like, you got to go by the same amount every time on your X and Y axis. So if we're going to go by 2s, go by 2s, but let's go by 2s the entire time. So how much does it cost just to get into his taxi? At 0 miles, it's going to cost $5. So it's in between here. It's going to be in between the 4 and the 6. So at 0 miles, you're going to be going, or you're going to be paying $5. So how we would write this using X and Y, since we have an X and Y axis, you'd say Y equals 2X plus 5. The thing that's happening over and over and over and over again is the 2. That's going to get your variable. That's going to be your, how it's increasing every time. You're going to be going up every time. And then the 5 is like where you start from. So your y-intercept, the b value is 5. The m value is going to be 2. The b value is going to be 5. So you're going to start where it's crossing the y-axis at 5. And then you're going to increase by 2 every single time. So the m value, if the m is 2, how you would write that in the form rise over run, or how you would write that in the form of slope, is you are going to rise 2 and you're going to go over 1. And since it's positive, you're going to go up 2. So you're going to go from 5 up to 7, and your run is going to be 1. So it's going to be right here. That says at 1 mile, you've paid $7. Because think about it, it's 1 mile, you know, that's $2, but you got to pay on that additional 5 just to get in this taxi cab. If you plot these ordered pairs and they don't make a straight line, you did something wrong. You got to look at it. You got to be alone with your thoughts for a little bit. You got to say, all right, if I don't get a straight line, if my next order pair is here and then my next order pair is here, that would suggest that, you know, you pay him this amount of money for this mile and then you pay this amount of money for this mile. That wouldn't have a constant rate of change. You're paying $2 every single time, so you are going to go up 2 over 1. So you're going to go from 7 to 9. So for 2 miles, it's going to be $9. For 3 miles, it's going to be $11. And let's think about that for a second. Let's stop. For 3 miles, 2 times 3 is 6. 6 plus 5, 11. That's what we have there. And we're going to put a line suggesting that it is going to keep going the same way on into infinity. It's never going to stop. It's never going to deviate from that amount because you're paying $2 every single mile. Okay? That's what your graph would look like. Our next example here, we're going to look at something that would be decreasing, meaning as X increases, the Y is going to decrease.